Good student. My name is Mr. Haruna from the Department of Mathematics. We're here to take our lecture 8 titled Complex Number. So, from our previous class titled Theory of Quadratic Equation, we discussed a quadratic formula ax squared plus bx plus c equals 0, which we call general quadratic formula or general quadratic equation. If you recall from Dr. Olubanwo's class, he solved quadratic equation using completing the square method, and then you arrive at an equation x equals minus b plus or minus square root of b squared minus 4ac over a 2a. Okay, now you arrive at this using completing the square method. This is where we are going to start from with complex analysis, because the discriminant b squared minus 4ac greater or equal to 0 have been well analyzed. Now, what happens when you have b squared minus 4ac less than 0? So this is where the complex number problems comes in. We want to analyze this discriminant b squared minus 4ac less than 0. So we are going to be using an example, to show this. So recall from the quadratic equation, the general quadratic equation, that you can have an equation of this form: x squared minus 4x plus 5 equals 0. If you compare with this, you have ax squared plus bx plus c equals 0. From your comparison, a equals 1 because the coefficient of x squared is a and the coefficient of x squared is 1. Also, b equals minus 4 because the coefficient of x here, is b, the coefficient of x here is what? Minus 4. So the constant here, c, equals 0. So when you come here and apply this into what you have gotten out here, you will get x equals minus b plus or minus square root of b squared minus 4ac over 2a. So x equals, what is your b? Minus 4. So you have minus 4 plus or minus square root of, what is your b again? Minus 4. So you have your minus 4 squared minus 4. What is our a? 1. And what is our c? 0. Sorry, our c is 5. Sorry, excuse me. Our c is 5. That's a mistake. So over 2. What is our a? 1. Okay, let's solve this. X equals minus negative multiplied by another negative gives you positive. So you have your 4 plus or minus. Then the square root of minus 4 gives you 16 minus 4 times 1 times 5 is 20 over 2 times 1 is 2. So let's proceed. So now we can say x equals 4 plus or minus, then 16 minus 20 gives us minus 4 over 20. Now this is where we are going. Square root of minus 4 is neither 2 nor minus 2. Because from the real number theory, we cannot have square roots of a negative number. So therefore, we will now bring the idea of solve into the problem. From our understanding of solve theory, we know that we can say square root of AB is equal to square root of A multiplied by square root of B. Is allowed because this is the solve theory. Hence, your square root of minus 4 is equal to square root of 4 multiplied by square root of minus 1. So, if you bring this back into the equation, you have x equal 4 plus or minus square root of 4 multiplied by square root of minus 1 over, what do we have now? 2, sorry. 2, which gives us x equals 4 plus or minus, the square root of 4 is 2, and then the square root of minus 1 is r over 2. By the time you split them, 4 over 2 plus or minus 2I over 2. 2 in 4 is 2, 2 in 2 is 1. Then you arrive at 2 plus or minus I. The I is referred to as the complex, and the 2 is referred to as the real. So, in a nutshell, the definition or the meaning of complex number is you have a real part and you also have the imaginary part, which is the I. So, we can proceed. I believe everybody understand what I did here, or what I did here is clear. Let me break it out so that we can have clear meaning of what's there. Now you have two solutions there. X equals 2 plus I, and also x equals 2 minus I. You cannot add 2 plus I because this is real and this is imaginary. You cannot subtract I from 2 because this is real and this is imaginary. So in a nutshell, this is our solution, this is our solution, and then it comprises of real and imaginary parts, which is why we say complex number. Okay, so now let's move on. Let's move on. In real number system, we know that we cannot have the square root of a negative number that has already been taken. So let's see how we can. Then we can now proceed with the understanding of I, because I have bring in I, and then we need to know what I is. You recall that I is equal to square root of negative 1. If that is the case, then you can say I squared is equal to square root of negative 1 and square root of negative 1 because it's squared. Hence, when you multiply root minus 1, and root minus 1, the answer is minus 1. We agree with this? So, you can say, okay, I cubed is equal to I squared dot I. In that case, we can say, what is our I squared? Negative 1 multiplied by I. So by the time we do this, we are going to have negative I. This is the power of a complex number. So you can keep on going to I raised to the power 4. Here you can say, okay, if I is raised to the power 4, then I squared dot I squared. Then you have, what is I squared here? Negative 1. What is I squared again? Negative 1, and then you have 1. This can continue, provided you follow the theory. But know that whenever you have I, you have root negative 1. Whenever you have I squared, you have root negative 1 multiplied by root negative 1, which gives you negative 1. For example, if you have 3 squared, you have 3 multiplied by 3. If you have the square root of root 3 multiplied by root 3, to you, the answer is 9, and root 9 is what? 3. So in that way, you can use it here. Root 1, root negative 1, root negative 1. By the time you find the 2, multiply the 2 together, you have negative. So let's now look at addition and subtraction of complex number, because this is sufficient for us, we can proceed. addition and subtraction of complex numbers. Let's take the addition first. In general, we can say Z1 equals X1 plus Y1 I. Recall that I said complex number will have real and imaginary parts. So this is your real, your X1 is the real part, and your Y1 is the imaginary part. So let's bring in Z2 rather. Z2 equals X2 plus Y2I. Now we can add the two together, but you will recall that X2 like X1 is the real part, Y2 like Y1 is the imaginary part. So when you have Z1 plus Z2, you are going to have X1 plus Y1 I, this is in bracket, plus X2 plus Y2 I, this is in bracket. So you had the real parts together. That is collection of like terms. And you understand it from secondary school. You can say, okay, X1 plus the real part here is X2. The real part goes to the real part, the imaginary part goes. But you have to be very careful of what is in the middle. But what we have here is addition, so you say plus. The imaginary part is Y1I plus Y2I. Hence, we can say X1 plus X2, this is the real part, they are together, plus Y1 plus Y2, the imaginary part, they are together, then you bring out your I, that is factorizing. So this is a clear method or a clear form of how to add the complex number. So let's look at an example of what we have just done. Let's say we have example 1. We have 7 plus 2i, okay, plus 3 plus 2i. We want to add this together. You recall that this is your real part, real part. This is your imaginary part. So hence you can say, you can call this Z1, you call this your Z2. So having Z1 plus Z2, you have 7 plus 2i, okay, plus 3 plus 2i. The real part goes to the real part, so 7 plus 3 together, then plus 2i plus 2i goes together. So 7 plus 3 is 10. 2i plus 2i. What does that give you? 4i. So the subtraction part. So Z1, if you recall, is your X1 plus Y1 I. And you know Z2 is your X2 plus Y2 I. So let's do the subtraction. Z1 minus Z2 equals X1 plus Y1 I minus X2 plus Y2 I. Recall the real parts goes to, they attract each other. So you have your real parts X1 and X2, they come together. But remember that this is negative. And this negative is operating along this path. Hence, you have, if you open it up, you can say X1 plus Y1 I minus X2 minus Y2I. This will help you because you already know that Y2, the imaginary part, carries one negative. Hence, you say X1, the second one is minus X2, then the first one here is plus. So you have your plus outside, Y1I, then followed by minus Y2I. Then you can factorize. Say x1 minus x2 plus y1 minus y2 in bracket. This is the subtraction of complex number. And it gives you another complex number. Okay? Let's take another example. Or let's use the first example as another example for the negative. Let's operate it. Let's operate it. So we can say Z1 equals 7 plus 2i plus, now this is, we are dealing with, okay, let's say Z2 now, equals 3 plus 2i. Okay, now let's now operate the negative sign. Z1 minus Z2. Okay, so we can use, okay, let's do that. Let's do that. Change all of this to brackets. You will see that I've been using brackets. So you can proceed. The first one is Z1, followed by Z2. We can open a bigger bracket for them to say 7 plus 2i minus the negative sign here, is Z2, 3 plus 2i. Okay, so Z1 minus Z2 equals 7 plus 2i. I would like you to be careful when you are doing this, the other part of this problem, because of this negative. This negative is very sensitive because it's operating with this bracket. Hence, you need to open it up very well before you collect the like terms. So you have minus 3, negative multiplying addition will gives you negative, because from your experience, plus times plus, it's plus, minus times minus, it's plus, minus times plus, it's minus, plus times minus, it's minus. You need to be very careful. This should be readily with you. And then you can say negative multiplied by addition, you have your negative 2i. So collect the like terms now. This is your real, this is your real, this is your imaginary, and this is your imaginary. Be careful, the real goes to the real, so you have 7 minus 3 in bracket. Then you have what here? Plus 2i. So you say plus 2i, then you have what? Minus 2i. Now you can say 7 minus 3 gives you what? 4. Now 2 plus 2i minus 2i is 0. So we agree, plus what? 0. So the addition of this one gives us just a real number, because the imaginary part is common from the operation of negative. So you can put it in bracket as well, and then you have your answer equal to 4. Now we like to take one more example before we move to multiplication, because you can be told to do something like this. Let's take this example. Express in the form x plus I. You have 5 plus 7i bracket plus 3 minus 4i into bracket plus 6 plus 3i. Okay, let's solve this solution. Now you are told to express all of this in this form. Technically, what they are saying is you are to add all of this together, because this is your Z1, Z2, Z3. You have 3 complex numbers. So you want to add them together. You can say Z1 plus Z2 plus Z3. Hence, you have 5 plus 7i plus 3i minus 4 plus 3, minus 4i plus 6 plus 3i. So, I told you the real part should attract. Hence, you have 5 plus 3. Be careful, 5, you have plus here, and you also have plus 6. Put them in bracket. Then the imaginary should also attract. So you have plus 7i minus, you have negative here, 4i, then plus 3i. Now you have 5 plus 3 plus 6. This is 8 plus 6 is 14. We have 14. Then 7 minus 4 is 3i. Okay, plus 3i gives you what? 6i. Now, you are told to write it in this form. So what is your x? If you compare, you have 14 plus 6i equals x plus yi. So what is x? X equals 14, y equals what? 6. That's what it means. Okay? So in case you are given something like this, that is how to solve that. Now let's move on to the multiplication part of the complex number. We've done, recall from the beginning that we started from the discriminant of quadratic equation, because from the theory of quadratic equation, from the theory of quadratic equation, you have done the discriminant of quadratic equation. When b squared minus 4ac is less or equal to 0, that is when you have your complex number coming in. When b squared minus 4ac is greater or equal to 0, you have actually evaluated that from the theory of quadratic equation taken by Dr. Rubamo. Now, recall also that I have done the power of a complex number where you have I equals square root of negative 1. Then I squared is square root of negative 1 multiplied by square root of negative 1, which it gives you negative 1 from your sword understanding of sword theory. Also, you have I cube, which is I squared dot I. I squared is negative 1. When you multiply by I, you still have negative I. That is a continual power of complex number. You can follow that step and do up to I raised to power 9, I raised to power 12, and so on and so forth. Now, we've also taken, recall that in this same class, we've taken addition of complex number. I've shown you that. I've also taken subtraction of complex number. I've shown you that. I believe with what we have taken so far, if you follow through from the beginning, you can solve, you can add 2 complex number, you can subtract 2 complex number. Now let's go to the multiplication part of complex number. So the multiplication of complex number. I will still continue with our z. Recall that z1 equals x plus y1, y1i, z. Then you have the z2 equals x2 plus y2i. Multiplication means you have to bring the 2 numbers together with multiplication power. So you have z1 dot z2, which gives you x1 plus y1i dot x2 plus y2i. Now, recall that when we're doing the addition, we are adding the real parts. Now, when we are doing the multiplication, you also multiply the like time there, which is the real part, multiply real part, and also it is like you want to open a bracket, actually. You want to open this bracket from your, bracket factorization problem. Now I will do this easily for you in the sense that I will use it as a distribution over one another. Like I will distribute this over this so that you can see what I'm doing. Now let's say you have Z1 dot Z2 equals the first one, X1 into distribute it over this X2 plus Y2 I. Okay? Then the second one, which is plus Y1 I over this X2 plus Y2 I. I hope this is clear enough. Distribute this over this and also pick this over this. That's it. Okay. Then you have X1 multiplied by X2, X1, X2, X1 multiplied by Y2. So you have plus X1, Y2 I. Don't forget. Then plus the same thing is happening here. You multiply this by this. So you have your X2, or you can say, for clarity's sake, let's say Y1 I X2. But I will prefer to write it the other way because of this I. So that's not to the parent. So you have X2 Y1 I. We say this is commutative in mathematics, but for now, just take it the way it is. Multiplication goes like that. Okay? Plus Y1 I multiplied by Y2 I gives you Y1 Y2 I squared. Remember, from our power of I. Now you can say X1 X2 plus, now let's bring them together. Okay, X1 Y2, there's I, okay, plus X2 Y1 all into bracket, put your I, because I is common to both, that's factorization, plus, now what is our I squared? Our I squared from the power of a complex number is -1. Hence, if you multiply the whole of this with -1, we are going to have minus Y1, Y2. So, this has changed to real from complex, it has changed to real. So, there's real here, there's real here. You can say X1, X2 minus Y1, Y2. Put it in bracket, then plus X1, Y2 plus X2, Y1 in bracket I. This is our solution. Now you can see we have our real parts and we have our what? Imaginary parts. Now let's take an example. I believe this is clear, or I can go over it again for clarity's sake and for those that didn't actually get that from the beginning. Let's see. Now if your X1 is recalled as this, your Z1 is recalled as X1 plus Y1 I, X2, Z2 equals X2 plus Y2 I. When you multiply the two together from your understanding of factorization, you recall that when you have A plus B into X plus Y, it's more or less like you want to multiply these two together. That is what is happening here. So if you want to do this, you distribute it over. You can say A into X plus Y, then plus B into X plus Y. That's what I did here. Now A times X give you AX, then A times Y give you AY, plus B times X give you BX, and B times Y gives you BY. Any of these can be distributed over another. If you are not distributing A, you can distribute these statics. You can say X into A plus B plus Y into A plus B. So X times A is AX, then X times B is what? BX, plus Y times A is AY, plus Y times B is what? Also BY. If you compare this with this, you will see that we have the same answer. So whichever one you are distributing will give you. So if you distribute this over this, it's correct. If you distribute this over this, it's also correct. So that is why we say in mathematics, multiplication is commutative when you are dealing with addition. But be careful when you are dealing with subtraction, it is not commutative. So let's now take an example on this. Let's take an example on this. Example. Z1 equals 3 plus 5i, and Z2 equals 2 minus 3i. Find Z1, Z2. This dot is multiplication, so solution. Z1 dot Z2 equals 3 plus 5i and also 2 minus 3i. So you have, remember I said you should distribute it. For clarity's sake, you must do that so that you will not mix them up, even though some can do it without distributing it. So you can say 3 into 2 minus 3i plus 5i into 2 minus 3i. So another person can decide to distribute this over this. You're still going to get the same thing. So Z1 dot Z2, Z1 dot Z2. Now 3 times 2 gives us 6. 3 times 3 gives us 9i. Also 5 times 2 gives us 10i. Then 5 times 3, remember this is negative, so you have 15i squared, because I dot I gives us I squared. Now equal to 6 minus 9i plus 10i. Now what is I squared? Recall I dot I is I squared, and that is square root of 1 dot square root of 1, and that gives you minus 1. So I squared here is minus 1. So you can say minus 15 into minus 1, which gives 6 minus 9i plus 10i. Negative 1, negative 15 gives us plus 15. Now, the real parts should come together, 6 plus 15. Then the imaginary parts should also go together. And then you can see that the real parts have positive, so you can say plus 10 minus 9i, because that's actually what's in it. So you have 6 plus 15 gives me 21. Then plus 10 minus 9 is 1. So 1 times I gives you what? I. So in that case, our solution, our Z1 dot Z2 equals 21 plus I. That's the correct answer. So you can see clearly how the multiplication goes. So you can look at it very well before we move to the next part. If your Z1 is this, Z2 is this, find Z1 multiplied by Z2. Now I said you can distribute it over. You can decide to use this over this, but I have used this over this. It's correct. So 3 multiplied by this means this is what I've written here. Then this multiplied by this is this. Now 3 times 2, 6. 3 times 3, 9. Now 5 times 2, 10. If 5 times 3, 15. I dot I gives me I squared. So I have shown you how I squared equals negative 1, which is what I've done here. Then 6 minus 9i plus 10i minus 15 times minus 1. Minus 1 here multiplied by minus 15 gives me plus 15. So the real part, I've told you that the like stand there must attract. So they must come together. 6 plus 15 is 21. Then minus 9i plus 10i is I. But you can do it the other way so that you see how clearly it is. Then 10 minus 9, I gives me 1. And this is 1. Let's take another example. Express I plus 2i 4 minus 5i and also 2 plus 3i in the form x plus iy. We did this for addition the other time, so we are going to do it for multiplication because it's very important to do this. Now, let's look at the solution. You have three terms then, Z1, Z2, Z3. So let's say Z1, okay, don't let's repeat that, let's just go straight to the point. 5 plus 2i into, let's do the last two first. Keep the first one. So you have 4, you can see that I use bigger bracket, that means I want to operate these two, then leave this for now. Minus 5i, another 2 plus 3i, let's close this bracket. Let's now operate this. 4 into 2 plus 3i, then minus 5i into 2 plus 3i. Remember that we still have the whole of this here. So you can bring it here and say 5 plus 2i. So that you will keep it and remember, you will not forget to multiply it. Now 4 times 2 gives me 8 plus 4 times 3 gives me 12i. Okay? Then minus 5 times 2 gives me minus 10i. Then minus 5 times 3 gives me minus 15i squared. Don't forget that. Then close the bracket. Remember this as well. Write it 5 plus 2i. Close it. Now, let your I squared here is -1, like we did earlier. So you have 8 plus 12i minus 10i, then minus 15 into minus 1. Then close it. You have 5 plus 2i. So, let's continue from there. So therefore, now let's proceed by saying 8. We want to continue from that place. Plus 12i minus 10i. Okay. Minus 15 minus 1 is plus 15. So you have plus 15. Close the bracket. Then the last part, which is 5 plus 2i. Now when you do this, 8 plus 15 gives me 23. So you have 23, 12 minus 10 gives me 2. So you say that plus 2i. Then you close it. Because we've done the real part, and this is the imaginary part. So another bracket is here, don't forget, plus 2i. Now we can now, multiply this. So doing this means we still do the distribution. Let's go over it again and see that we're doing the right thing. 4 times 2 is 8, 4 times 3 is 12, 5 times 2 is 10, 5 times 3 is 15. Okay, I squared is 1 minus 1. So when you multiply that, you have positive 15. So we are doing the right thing. Now, if you want to proceed from here, we distribute again over. So you have 5 into 23 plus 2i. And also, you can say plus 2i into 23 plus 2i. So 5 times 23 gives me, you can say 23 by 5. This is 5, 1, this is 10, and that's 11. So 115 plus 5 times 2, 10i. Then 2i by 23, that is 46. So we say plus 46i. 2i multiplied by 2i gives me 4i squared. So 4i squared. I squared itself is -1. So you have 115 plus 10i and 46i gives me 56i. When you add that together, then plus 4 into -1 because I squared is -1. So which is equal to 115 plus 56i minus 4. Now let the like terms come together. So 115 minus 4 plus 56i, which gives us 111 minus 56i. This is our final answer. So this is already in the form x plus iy. Because here now x is equal to 111 and y is equal to what? Minus 56. Now be careful, there's a negative sign here. If it is positive, that is when y is positive. But because you have negative 56i, so your y is negative 56. So that is that on the multiplication. I believe this is clear enough. So if you have 3 brackets as we have it, you can take any 2, because we said earlier that multiplication is commutative under it's commutative when you have addition. It is when you have subtractions and you get you don't have commutativity in that sense. So here we have 3 brackets. It's either you do this first or you do any one first. You can take any 2 because of the commutativity property. You can take these 2, or these 2 first. But make sure that whichever one you are doing, you don't forget the last part of it, as we have carried it over throughout the whole solution process. Okay, let's move on now. We can now go to the conjugate of complex number. Like we have in sum, when you have sum as the square root, you rationalize it. And in the process of rationalizing it, you multiply by the conjugate. But in this case, we have complex number, and then we can have the conjugate of complex number. What do we mean by that? Let's see what we are saying. If you have z equals x, sorry, that's right, conjugate of complex number. If you have z equals x plus iy, the conjugate of this is z bar, okay, equals x negative iy. That's what we mean by conjugate. So you can multiply a complex number by its conjugate. Yes, we do that a lot because we do it in set. In sort. So you have z dot z bar. Let's multiply these 2 together, because this is the conjugate of this complex number. So you have x plus iy into x minus iy, because we want to multiply by its conjugate. So z dot z bar equals x times x. That's let's distribute it like we have been doing, so that we will not mix it up. We've been distributing it since. So let's continue with that form. Though I said earlier that we can do it direct, it's not compulsory to do the distribution, but let's maintain that particular form. Now x distributed over this minus iy, then plus iy into x minus iy. Okay, so x times x gives me x squared. X times iy is minus xyi. The same thing is here, plus x times iy, you have I xy or xyi. Case maybe xyi. Now iy negative iy. When you multiply that together, you have plus times minus gives you minus. Then you have y squared I squared. So you know that I squared is negative 1, or I squared is negative 1. So you have x squared minus xyi plus xyi negative y squared into negative 1 because of this I squared. So you have x squared. Now negative yi I plus negative xyi plus xyi. This is 0. They negate each other, so that's gone already. So you can now say that what you have here is going to be minus times minus is going plus, then your y squared remain. So this is your solution. You have, when you multiply a complex number by its conjugate, it gives you the real part, the real number. Okay, so now we can proceed. With an example. Let's find a complex number and multiply that conjugate. Let's use one of our previous example or any of those numbers from there. So let's take example. If you have z equals 5 plus 2i, the conjugates, if you want to multiply by the conjugate, you have the conjugate gives you 5 minus 2i. So you want to multiply by, so you say z dot z bar, which is the conjugate. So you say that 5 plus 2i into 5 minus 2i. There's something very interesting here. When you multiply a complex number by its conjugate, it gives you a real number. That should be something you must be familiar with. So when you see something of such in any exam or test, you know that when you multiply a complex number by its conjugate, it gives you a real number. Now, distribute it over, like we're doing, 5 into 5 minus 2i, then plus 2i into 5 minus 2i. 5 times 5 gives me 25. Then 5 times 2, we have 10i plus 2 times 5 also 10i. Then 2 plus 2 times minus 2 gives me minus 4i squared. Recall that I squared is negative 1, like we have been doing. So 25 minus 10i plus 10i is 0. It's gone. So you know that I squared is negative 1. So negative 1 by negative 4, that is minus 4 into minus 1, that is what is happening here. This gives me 4. So you come here and say plus 4, and your answer is 29. So when you multiply this by its conjugate, the answer gives you 29. So now let's proceed to the next part, which is division of complex number. So now we'll proceed with the class. Let's take division of complex number. We've done record, we've done addition, we've done subtraction, we've done multiplication, we've also taken the conjugate. Now we want to take the division of complex number. So when you have division of complex number, okay, let's z1 equals x1 plus y1i, and you have your z2 equals x2 plus y2i. Now z1 divided by z2 equals x1 plus y1i over x2 plus y2i. I believe what I've just written here is basic division. And you know, when you say 2 divided by 3, z1 divided by 2, which is what you have. But you can't have it this way. Like I said earlier, in your sum, 2 root 2. You can't leave it like this. You multiply by the conjugate, which is, you know, if it is 2, for example, root 3, what you do here is say the numerator, which is 2 times root 2 plus root 3. What you did here is multiplication of what? The root by the what? The conjugate. So in that case, we will use that same format here. We multiply the numerator by the conjugate of the denominator, and we also multiply the denominator by the conjugate of what? The denominator. So hence we say the first one multiplied by x2 minus y2i and also the down part, the denominator, by x2 minus y2i. You know the denominator is already a conjugate of itself like this from our explanation of conjugates. When you multiply a complex number by its conjugate, it gives us real number. So it will eliminate the complex part of the denominator. Let me repeat that. When you multiply a conjugate, a complex number by its conjugate, it gives you a real number. So when you multiply this, you have a real number at the denominator, which eliminates the complex number at the denominator, which is what we want to achieve. Now, we say z1 over z2 equals, distribute it, x1 into x2 minus y2i, then plus y1 I into x2 minus y2i over, do the same thing for the denominator, x2 into x2 minus y2i, close it, then plus y2i into x2 minus y2i. Now what I have done here is what I have been doing since we started the class. I did not just want to expand the brackets, I want to do it, distributing it over one another. So z1, z2 equal x1, x2 as the first part, minus x1 times y2 gives me x1, y2i. Okay, go to the next part, plus x2, y1i. Then go to the next part, plus times minus gives me minus. So y1, y2 gives me y1, y2. I times I gives me I squared. So divided by, you know that everything is still there. So you have x2 multiplied by x2. You can argue, or you can say it's s2 squared. You can say s2 multiplied by s2. You can also say s2 squared. So now you have minus x2 y2i. Okay, then you go to the next part, plus y2i, sorry, y2 x2i, this is it, y2i multiplied by x2, y2 x2i. Now, negative multiplied by positive gives me negative. Now, y2 multiplied by y2 is y2 squared. So, I dot I gives me I squared. Now, let's continue. So, we have our z1 over z2 equals, now recall that x2 y2i plus y2 x2 cancel because this is negation of one another. Say minus 10 plus 10 gives me 0. So that's what is happening here. So this already gives me 0. I will be left with x2 squared minus y2 squared I squared. But for this one, that is not happening. You have to be careful, so you can say x1, x2, the first part. Now recall that I squared is -1. So -1 minus I1, I2 gives me plus y1, y2. That is certain there. Then this one I've written that. So let's put it together. So you have plus y1, y2. Put it together. So I've added that. Now this one here, minus x1, y2, I plus x2, y1, I will remain because they can't cancel each other, but we'll factorize it. So put this one in bracket and say plus another bracket x2, y1, then minus x1, y2, everything in bracket. I include the bracket. So now recall that we have eliminated this will cancel this because it's 0. Then you have x2 squared minus, now it's supposed to be x2 squared minus y2 squared, but recall that I squared is equal to minus 1. So I squared, which is minus 1, times minus y squared, y2 squared will give me plus. So this is plus y2 squared. So z1 over z2 gives me x1, x2 plus y1, y2 to bracket plus x2, y1 minus x1, y2 I over x2 square plus y2 square, which is the answer. So now you can see when you divide, sorry, we are dealing with division of complex number. When you divide, you have to be very careful, because when you are doing the division, you have to multiply the numerator by the conjugate of the denominator, and you also have to multiply the denominator by the conjugate of itself. So when you do that, this is what you arrive at. And also, let's take it over again. So that we're clear of what we are doing. Now, when you are doing the multiplication, the table, so you have x1, I distribute it over, I pick this to distribute over this. So x1, x2 minus y2, then y1, I over this as well. x2 minus y2. So this is distributed over this. This can also be distributed over this. You will get the same answer. Like I said earlier, it's quantitative. So x1, x2 gives me x1, x2. x1 minus y2 gives me minus x1, y2i. Also plus y1i times x2 gives me x2, y1i. Then if you multiply this by this, plus and minus is minus y1, y2, y1, y2 square. I square, I calculate I. So then also x2, x2 is x2 square. We multiply it. Then x2, y2 gives me minus x2, y2i. Also plus y2i, x2 gives me y2, x2i. Then also plus times minus gives me minus y2, y2 is y2 square. So I dot I is x2. I believe that is clear enough for us. So that is how we arrive at that. Let's take an example of that in case we are faced with something like this. So I believe this is clear enough for us to see. So if we want, let's take an example so to be much more clear with a numerical example. Now you have example. Simplify. Simplify. 7 plus 5i over 6 minus I. Now this is your Z1, Z2. So say Z1 divided by Z2 equals 7 plus 5i over 6 minus I. What is the conjugate? What are we multiplying by now? We are multiplying by 6 plus I. That's the conjugate of the denominator. So you say equals 7 plus 5i multiplied by 6 plus I over 7 plus 5i, then 6 plus I. Okay, I hope this is clear. We are multiplying by the conjugate of the denominator. So Z1 over Z2 equals, now let's simplify. Okay, 7 times 6 is 42. So you have 42. Okay, don't let me do it. Let's distribute it like we have been doing. 7 into 6 plus I, okay, plus 5I into 6. Okay, divided by 7 into 6 plus I plus 5I into, oh no, sorry, and 6 minus I. That's the easy. So let's explain this. So you have 6 and I into 6 minus I. That's the distribution. Okay, Z1 over Z2 equals 7 times 6, this is equal to 2. 7i. Okay, 5 times 6, this is 30. You have 30i. Then 5 times 1 is 1. The quotient of I is 1, so you say plus 5i squared. That's what you have. Over 6 times 6 gives me 36. Then 6 times I, you have 6i. Also, when you multiply this, you have, sorry, this one should be negative. We are distributing this over this, so it's negative, sorry. So this is going to be I times 6, you have minus 6I. Also, I times I will be plus I squared. Okay, so Z1 over Z2 equals, now 5I squared is minus 5. You will recall that I squared equals minus 1. So that's minus 5. So you have 42 minus 5. Okay, plus 7I. 7I plus 30I gives me 37I. Okay, so you have 37I over, okay, 6I. 6 times 6 is 36. 6 times I, that's plus 6 plus this 6 times I, that's plus 6I. Then also, sorry, this is minus 6I. And then this times this is plus I squared. Sorry for the mistake. It's an error there. The distribution should be very late, like we have done it. So recall that the conjugate, when they multiply, it gives us the real number. It's a real number when you multiply the conjugate number. So minus 6 plus 6 is 0. This will cancel out. So 42 minus 5 plus 37, then 6. Now I squared is minus 1. Recall, I squared is minus 1. So 36 minus 1. That's what you have. We have 36 minus 1. So Z1 over Z2 will give me 42 minus 5. That is 37. So 37 minus 37I over 35. You can still factorize this. So you have 37 minus 37, that's 37. 37 into 1 minus I. Okay, it's plus. Thank you. Also, this one is plus. Thank you. So this is the correct solution. Now, when you simplify this, that is what you have. I believe this is clear enough for us to see. So division of complex number is direct and straightforward. And also, we can learn this. Okay, sorry student, we need to look at this again. Now this is what we are doing. The conjugate of this is 6 plus I, which is what we have done. Now, when you are distributing it, you have to be very careful. What we did is distribute 7 over this and 5 over this, which is what we have done. Now, we want to distribute this over this. So that means this is going to be positive, because this is 6 over this, and minus I over this. This is plus, not negative. So that will change our solution here. So sorry for that mistake. So that distribution you must always observe and watch. So which means 7 times 6 is 42. Then 7 times I is 7I. Also plus 30I. Much will not change from our solution though, but because of that negative. Then also this is 5I squared over, now 6 times 6, 36, plus 6I minus 6I, and this will be what? Negative I squared. Okay, instead of the positive we have earlier. Now this, we cancel this. 36 I squared is minus 1, don't forget. And so when you multiply again by negative, it gives you plus 1. So the whole of this is plus 1, plus 36. Now you have Z1 over Z2 equals 42. Now this is going to give you minus 5, because I squared is minus 1. Minus 1 times 5 is minus 5. So 42 minus 5. That's what we have there. Then plus 37. Put this in bracket. Plus 37 I. When you had 7 plus 30, 37 over 36. Recall that this is plus 1 because I is negative 1 multiplied by this is plus, so we have 36 plus 1. 36 plus 1. Z1 over Z2 equals 42 minus 5 is 37 plus 37I over 37. So you can factorize it. So 37 into 1 plus I over 37. So this will cancel out. The answer is 1 plus I. That's the final answer there. So I believe this is clear enough now. I'll go over it again. We'll understand. Just multiply by conjugate. The conjugate of this is 6 plus I, which is what I have done here. 6 plus I. Then distribute it over, which is what we have done. Also distribute over, and then we arrive at that. So I believe this is clear enough for us. And then we've done addition, we've done subtraction, we've done the multiplication, and we've taken the division as well. And also don't forget that we have taken the power of complex numbers, so that is I squared, I raised to power 3, I raised to power 4, and it can be continuous like that on to nth term, like. So thank you very much.